students, in the previous lectures and before that also, we have studied the application of linear programming problem with the help of Excel in the area of marketing, finance and operations. In each area we have taken some problem, then we have solved it. Now, we are going to use some advanced linear programming applications in business. So, today we are going to, I am going to teach data envelopment analysis with the help of linear programming problem. So, the agenda for this lecture is data envelopment analysis, that we are going to use LP for solving this data envelopment analysis. First, you should know what is this DEA, where it is used, how this DEA method, data envelopment analysis, has connection with the LP. So, this DEA is used to measure the relative efficiency of operating units with the same goals and objectives. Okay. Assume that in a city there are say different restaurants and the same company name, banks, say even can be used for comparing the performance of different IITs. So, where the now the NIRF is used like this DEA analysis can be used for comparing the performance of IITs, IIMs, or the same within IIT different departments performance can be compared. This is relative performance. Here the another advantage of this DEA is where we can consider multiple inputs and multiple output. For example, if you take a restaurant, so in a city there are 5 restaurants, say restaurant chain for maybe restaurant 1 in different part of the city 1, 2, 3, 4, 5. Okay. Then operation manager, so he is willing to compare the relative performance. So, that relative performance can be done with the help of this data envelopment analysis. There are many research papers they have used this DEA. For example, if it is a restaurant, what are the multiple inputs is possible? The staff size is one of the input, salaries, hours of operations and advertising budget. Obviously, when the staff size is more, the output will be more, salary is more, that is the indirect way of representing the inputs. So, in a restaurant context, what are the multiple output? Profit, market share, growth rate, these are the multiple outputs. So, it is often difficult for a manager to determine which operating units are inefficient in converting their multiple inputs into multiple output. So, whenever this kind of problem arises, the DEA, that is a data envelopment analysis, is the most suitable method. Now, I have taken a sample problem. This example is taken from the book Anderson et al. So, evaluating the performance of hospitals. Okay. We are going to consider 4 hospitals. Out of these 4 hospitals, we are going to measure the relative efficiency. Okay. So, which hospital is efficient, which hospital is inefficient. So, we are going to consider 3 input. One is number of full time equivalent non-physician personnel, amount spent on supplies, number of bed days available. These are the inputs. Output is there are 4 output: patient days of service under Medicare, patient days of service not under Medicare, number of nurses trained, number of interns trained. Okay. So, 3 inputs and 4 objectives. This table shows the input. Okay. So, there are 4 hospitals, general hospital, university hospital, county hospital, state hospital. You see in the general hospital, so 285.20 is the full time equivalent non-physicians, 123.80, okay, the values in terms of 1000 is the supply expenses. Okay. Bed day available, Okay. When there are bed day available means when there are more number of beds, there are more number of bed days available, 106.72. Okay. Like that there are 4 hospitals. So, when you look at this county hospital, for example, here this is the highest value, yes, 348.5010. Okay. So, now we are going to measure the efficiency of county hospital when compared to other 3 hospital. So, these are the inputs. Similarly, we can consider the output of these 4 hospitals. What are the outputs? Medicare patient days in terms of 1000. This is the annual input and annual output. You should be very careful on the units, because these are annual amount of input resources used. This is annual amount of output produced. So, non-Medicare patient days 43.10 in terms of 1000, nurses trained 25.3, interns trained 41. Like that, for there are 4 hospitals. Now, we will go to the overview of data envelopment analysis approach. So, this can be solved with the help of linear programming problem. So, what we are going to consider? We are going to consider an hypothetical composite hospitals. Okay. This hospital has, we are going to make some assumptions. What are the assumptions? The output, okay, will be always greater than the individual hospital. So, this is a composite hospital, this is composite. Okay. So, what we are assuming about this composite hospital is that it is going to always going to produce more output than the individual hospitals. That is why this is output is greater than or equal to. Second assumption is that it is going to take lesser inputs. So, inputs are lesser when compared to individual hospitals. So, we are going to formulate a linear programming problem for only composite hospitals. By looking at the efficiency or the performance of composite hospitals, we are going to compare the efficiency of other 4 hospitals. Okay. So, linear programming model, we are going to consider different weightages. So, Wg is the weight applied to inputs and outputs for general hospital, Wu weight applied to inputs and outputs for university hospital, Wc weight applied to inputs and output for a county hospital, Ws weight applied to inputs and output for state hospital. Since it is weight, so the sum should be 1. This is one of the constraint. Okay. Now, we are going to take only one output, for example, Medicare patient days for composite hospitals. So, I am going to find out the Medicare patient days for composite hospital. How I am calculating? So, Medicare patient days for general hospital multiplied by its weight, Medicare patient days for university hospital multiplied by its weight, Medicare patient days for county hospital multiplied by its weight, Medicare patient days for state hospital multiplied by its weight. So, the Medicare patient days for composite hospital is 41.14 Wg plus 34.62 Wu plus 36.72 Wc plus 33.16 Ws. Where we got this? I got from this one. You see this is output. There are 4 individual hospitals. So, here for composite hospital we brought it here. So, the output of Medicare patient days for composite hospital is this one, 48.14 Wg, 48.14 Wg plus 34.62 Wu plus 36.72 Wc plus 33.16 Ws. Like this, there are 4 outputs. We can write constraint. Okay. We can write 4 output for the composite hospital in similar way. So, we know that the output of the composite hospital is greater than output of county hospital. So, what we are going to do? We are going to compare, we will go back to the previous slides, we are going to compare efficiency of county hospital with respect to efficiency of composite hospital. Okay. Now, the problem is we are going to compare two entities, one is county hospital versus composite hospital. So, what we are assuming, the output of composite hospital is greater than, because the composite hospital is more efficient, is greater than output for the county hospital. So, I have written 4 outputs for composite hospital. So, this is 1, 2, 3, 4. Most important here is this is greater than equal to. So, how I got this 36.72? This is output of Medicare patient days for county hospital. So, I will go back, this is this one 36.42. So, I will go back, see this is 36.42. So, how I am writing this? The output of Medicare patient days, okay, is greater than output of the county hospital for one variable, that is Medicare patient days. That is why I have written like this. For second output, so these values 36.72, 45.98, 175, 23, these are only for county hospital. The left hand side value is output for the composite hospital. Okay. Now, I am going to create another set of constraints for the inputs. So, the relationship between input measures for the 4 hospitals and the input measures for the composite hospital. As I told you, the input for composite hospital is less than resources available to the composite hospital. Okay. So, for example, the number of full time equivalent non-physicians, okay, for the composite hospital. So, 285.20 Wg, 162.30 Wu, 275.70 Wc plus 210.40. This is the resources, this is the composite, okay, composite input. So, the logic of DEA is to determine whether a hypothetical composite facility can achieve the same or more output while requiring less input. Okay. There are two things we are comparing. One side, this is composite hospital, another side we have the county hospital. So, what we are saying that whether this hypothetical composite facility can achieve same or more output while requiring less input. So, this fellow composite hospital, whether if he is achieving more output than the county hospital by consuming lesser resources, we can say this composite hospital is efficient. What is this? The composite hospital is going to produce more output by using lesser resources than the county hospital. Okay. Then the composite person is more efficient. So, if more output with the less input can be achieved, the facility being evaluated is judged to be relatively inefficient. So, county is inefficient, but the composite is efficient because this fellow is achieving more output with a lesser input. To consider that composite hospital is going to consume more, going to produce more output by consuming lesser resources, we are going to deduce a new decision variable E. the E represents efficiency index. The value of E, there are three possibilities. If E equal to 1, what is the meaning? The fraction of county hospitals input available to the composite hospital. That means the inputs utilized by composite hospital and county hospital is same when E equal to when E equal to 1. So, when E equal to 1, the total number of full time employees non-physicians available to the composite hospital is 257.70. We will go back where we get this 257.70, we are talking about input, this one. That means that the composite hospital is going to consume lesser resources than the resources of county hospital. That is why written 275.70. We will go back again. Yes, both are consuming equal amount of resources when E equal to 1. When E is greater than 1, the composite hospital would have available proportionately more non-physicians. That means that composite hospital is consuming more resources than the county hospital when E is greater than 1. When E is less than 1, the composite hospital would have available proportionately less non-physicians. But we have assumed that previously that composite hospital is going to consume lesser resources than the county hospital. So, we have to minimize this E. Okay. Now, look at the constraints for input. So, this is the composite constraint. So, the E represents percentage of resources utilized by composite hospital. If the value E equal to 1, so the resources utilized by composite hospital and county hospital is same. When E is greater than 1, so the composite hospital is consuming more resources than the county hospital. When E less than 1, the composite hospital consuming lesser resources than the county hospital. We know that in the beginning I was saying that composite hospital is more efficient. So, here the objective function is in a DA model is always minimizing E. What is the meaning of this minimizing E? The facility being evaluated, for example, county hospital in this case, can be judged relatively inefficient if the optimal solution provides E less than 1. What is the meaning of E less than 1? Indicating that the composite facility requires lesser input resources. So, what we have to do? We have to minimize the E. If the value of E is less than 1, what it implies? That composite hospital consuming lesser resources than the county hospital. Okay. Now, we will go for LP formulation. If E equal to 1, the composite hospital requires as much input as county hospital does. So, there is no evidence that the county hospital is inefficient. But if E less than 1, the composite hospital requires less input to obtain the output achieved by county hospital. Okay. So, the composite hospital is more efficient, thus county hospital can be judged relatively inefficient. So, in the data envelopment analysis, we are going to minimize the value of E. Yes, that is the minimizing the E. What are the constraints? This is the weightage constraint. These 4 constraints for output, because we are solving for only composite hospital. Okay. You remember this LP formulation is for composite hospital. So, we know that composite hospital is more efficient. So, they are going to produce more output than the county hospital, that is why it is greater than for the output constraint. For the input constraints, so only a fraction of input resources of county hospital is going to be considered by the composite hospital. So, that fraction is written as E. That E we know that it is going to be less than 1 or equal to 1. So, I have readjusted, I brought this E on the left hand side. So, here it is less than or equal to type. So, this is our complete linear programming problem for a composite hospital. So, now I am going to solve this problem, I am going to find out the value of E, then I am going to interpret. Now, I will go to the Excel. Now, I am going to use a solver to get the output for our data envelopment analysis. So, here for example, in D4 to H4 is our value of decision variables. In our objective function only E is there. So, only then 1 should be there. Then I have written there are 8 constraints. In I7 to I14 I have written the resources utilized. So, K7 to K14 I have written the right hand side. So, the value of objective function is D16 as usual as per the constraint. So, here this problem is minimization problem. Now, I will go to data, then go to solver, then you see that it is a minimization problem. Changing cell is as I mentioned, there is 1 equal to type constraint, there are 3 less than or equal to type constraints and 4 greater than or equal to type constraint. So, now I am going to solve it. I need answer and sensitivity analysis limits, click it. Now, I have the answer report is there, sensitivity report is there. Now, I will go to sheet 1 where I can see the value of E. The value of E is 0.905. Okay. Now, I am going to take this output of this Excel sheet into the presentations. From there, I am going to interpret the output. The value of E is 0.90. When you look at here, this is the both this and this is equal, but you see that there is it is greater than or equal to type. So, it is a surplus variable. Here also it is a surplus variable. Okay. So, this is the output. Now, we will interpret this solver output. So, value of the objective function shows that the efficiency score for county hospital is 0.905. Remember, we have solved for hypothetical composite hospital, but this is the efficiency for the county hospital. What is the meaning of this 0.905? This scores tells us that the composite hospital can obtain at least the level of each output that county hospital obtains by having available no more than 90.5 percentage of the input resources. So, this fellow, the composite hospital, right, is going to use less than 90.5 percentage of resources consumed by the county hospital. That means this fellow, this composite hospital is consuming less resources. So, the composite hospital is more efficient. If this fellow is composite is more efficient, obviously the county hospital is inefficient. So, what we are inferring, the composite hospital is more efficient because this fellow consuming lesser resources, only 90.5 percentage of the county hospital, and the DA analysis identified county hospital is being relatively inefficient. So, now we have done only for one hospital. Like this, the same procedure has to be continued for all other 4 hospitals. Then we can see relative performance of all 4 hospitals, that you should be remember. Now, there are some slack variables there. Slack variable is there. There are some surplus variables there. Okay. The value of E is 0.905. So, now I will interpret this. So, the slack and surplus column provides some additional information about the efficiency of the county hospital compared to the composite hospital. Here, this column. the composite hospital has at least as much as the composite hospital has at least as much of each output as county hospital has and provide 1.6 more nurses trained and 37 more interns trained, because this is a surplus variable. Look at here, these two. Okay. So, it is surplus variables. Surplus means it is the constraint is greater than or equal to type. So, the composite hospital is training more, how many nurses? 1.6 more nurses and 37 more interns, but by consuming only 90.5 percentage of the resources of the county hospital. So, the slack of 0 for constraint 8 shows that the composite hospital uses approximately 90.5 percentage of bed days used by the county hospital. So, here bed days available here is here. So, what is the meaning of slack 0 means? So, the composite hospital is utilized only 90.5 percentage of the bed days available for the county hospital and it achieves equivalent output of county hospital. So, we say composite is more efficient, that is why county become inefficient, that is the meaning of this 0 slack. Now, the slack variable for constraint 6 and 7 shows less than 90.5 percentage of full time employee of non-physicians and supplies, expenses, resources used at county hospital are used by the composite hospital. Okay. So, what is the meaning here? That there is a slack variable. Okay. So, it says that the composite hospital has utilized less than 90.5 percentage of resources of county hospital. Okay. That is the meaning of this slack. Slack means that it is unutilized resources. County hospital did not utilize this much resources. Very important point you should remember that the goal of data envelopment analysis is to identify the operating units that are relatively inefficient. This method does not necessarily identify the operating units that are relatively efficient. So, what is the meaning? Just because the efficiency index E equal to 1, we cannot conclude that the unit being analyzed is relatively efficient. So, the focus here is more on to identify which unit means decision making units, they call it as DMU, decision making units are inefficient. So, in this lecture I have explained the application of data envelopment analysis. So, I have taken one applications, that is comparing the relative efficiency of 4 hospitals. So, that problem I have formulated with the help of linear programming problem, then I have solved it, then I have found the relative efficiency of that hospital. Thank you very much.